Today we're going to get an introduction to logic. And so this is going to be a pretty intense, I don't know if it's intense, but it's going to be a pretty heavy video in terms of a lot of new terms. And so, make sure you're pausing the video, taking good notes, and rewinding it if you're getting confused on anything. Okay, so we're going to learn about Euler diagrams, conditional statements, hypothesis, conclusion, converse instance, and counterexample. We're going to learn all those terms and what all those things mean in this video. Okay, let's start. So this is an Euler diagram. And what this is showing is it's kind of like the big family of fruit. And in that big family of fruit, there's a small subsection of apples. And so this shows that all apples are fruit, but there are some fruits that are not apples. So over here, there might be bananas, pears, mangoes, raspberries, and so on. Those would all be outside of this apple circle. Okay, so this is just called an Euler diagram. It's kind of showing the big family and then the small subset on the inside. Okay, so let's start moving stuff. Where do these things belong? So banana, and I would encourage you to pause it and try to think about where would these things go? Where am I going to put them? So banana is going to go in the fruit section, not in the apple section. Corn is not a fruit, so we're just going to keep that outside. Oranges are fruit. They're going to stay in the fruit section, but not in the apple section. A Granny Smith, this is a type of apple, so I'm going to put that in the apple circle. So this is saying a Granny Smith is a fruit. It's also an apple. A Red Delicious is another style of apple, so that's going to be in the apple family. And then green beans, those are not fruit, so they're going to stay on the outside. So these are some examples of how you might set up an Euler diagram. Most of the time, you're just going to see Euler diagrams that look like this. Okay, so this statement here would be all apples are fruit, because all the apple circle is inside this fruit rectangle. So if I move the apple circle to like here, this would signify that some of the apples are not fruits, but some of them are. But apples are all fruits, so that would be this statement. And it can be written as a conditional. So a conditional statement, this is one of the terms for the day. A conditional statement is an if-then statement. And I also mentioned at the top of the video that we're going to learn about hypothesis and conclusion. And in science class, it's something totally different. A hypothesis in logic is the stuff after if. That might be something worth writing down if you're taking notes here. The hypothesis is the stuff after if, and then the conclusion is the stuff after then. So a conditional is an if-then statement. The first part is the hypothesis after the if is not included. And then the conclusion is the stuff after then. So we would write this conditional like this. If something is an apple, then it is a fruit. So one of the things you might be asked to do as a geometry student is to identify what's the hypothesis and what's the conclusion. So the hypothesis, like I said, is the stuff after if. So the hypothesis is something is an apple. It's not if something is an apple. The hypothesis is something is an apple. And then the conclusion is it is a fruit. So when you're asked that on some homework assignment someday, when they ask for what's the hypothesis and what's the conclusion, you would do the stuff after if and then the stuff after then. All right, let's look at the converse. This is another term that I had mentioned we're going to talk about. The converse is a statement in which the hypothesis and conclusion are exchanged. So what I mean is they're flipped. So now the conclusion becomes the hypothesis, and the hypothesis becomes the conclusion. So let's take a look at this. I said in the previous statement, if something is an apple, then it is a fruit. So the converse, we're going to take and flip it around. We're going to write it, if something is a fruit, then it is an apple. And we got to be conscious of our pronouns and stuff. We wouldn't just pull these four words. We wouldn't say, if it is a fruit, then something is an apple. We would say, if something is a fruit, then it is an apple. Okay. And these don't always have to make sense. They don't always have to be true. We're just going to rewrite it as a converse. So let's ask that question. Is the first statement true? If something is an apple, then it is a fruit. And that would be true. Yeah, all apples are part of the fruit family. So that's true. The second statement, so is the converse, that's the second statement. Is this true? If something is a fruit, then it is an apple. And so when I say is it true, I mean is it always true? Not is it sometimes true, or can you find one example where it's true? If you can find one example where this is not true, then it's false. And so if something's a fruit, then it's an apple, that is false. Because we could say bananas, we could say oranges, mangoes, I kind of listed some off earlier. As long as you can find a fruit that's not an apple, that makes the converse false. Okay, so let's talk about that. I mentioned some instances and some counterexamples. An instance is something that makes a conditional statement true, and a counterexample is something that makes a statement false. So an instance happens when the hypothesis is true and the conclusion is true, and they're always true. So when both of these are true, that would be an instance. If the hypothesis is true and the conclusion is false, that would be called a counterexample. And we'll look at something here. So if an animal is a bird, then it can fly. So what would be an instance of this? So a bird, let's say something that's a bird that can fly, well, I mean, that's pretty much everything. Let's say a duck. A duck is a bird, true, and a duck can fly, true. So then I want to come up with a counterexample. So are there any birds that can't fly? And so the answer is yeah, there's a couple. There's not many, but an ostrich is a bird. So is an ostrich a bird? Yes. Can it fly? No. And so sometimes you'll see people put like a bee, because a bee can fly, but it's not a bird. But remember, for a counterexample, the first part has to be true, and then the second part has to be false. So is a bee a bird? No. So automatically it's not a counterexample. It's not an instance. We say that it's neither, and that's what we would write down. Okay, so let's look at this statement. If the shape is a square, then it has four sides. So what is the hypothesis? Well, the hypothesis is a shape is a square. Okay, what is the conclusion? Well, it has four sides. Okay, is this statement true? So if the shape is a square, will it have four sides? Absolutely, that is true. Squares have four sides. Okay, write the converse. So I'm going to type this to save some time. The converse would be if a shape has four sides, then it is a square. Okay. Is the converse true? So if something has four sides, a shape has four sides, then does it have to be a square? So if you ask a kindergartner this, the answer is yes. But if you ask a high schooler this, the answer is no. That is not true. So this is false. And why is it false? Well, there are a lot of other four-sided shapes. There's a rectangle, there's a rhombus, there's a parallelogram, trapezoid. There are other types of four-sided shapes that are not squares. So it would be false. All right. So let's look at this then. There's one more statement here. It says, if it is December, then it is cold outside. And let's type this in again. So what's the hypothesis? It is December. What is the conclusion? It is cold outside. Is this statement true? So I would argue, well, it depends, but it's not true. Where we live in Minnesota, it seems like it's always true, but this is false. If you head to Mexico, say you go to Cancun in December, chances are it's not going to be cold outside. So if it's December, then it's cold outside, that's not true. So it would be false. You could say in Cancun, or maybe even you're down in Australia where the summer and winter are flipped from where we are. So that would be false. Write the converse. All right, so let's type that in. We're going to flip it around. So we're going to say if it is cold outside, then it is December. Okay, is this statement true? So if it's cold outside, then does it have to be December? And of course, that answer is false as well. It could be cold anytime. It could be cold in January. It could be cold in February. Sometimes it's cold in Minnesota in June. So if it's cold outside, then it's December. That is not true. All right, one more slide here, and then we'll be done for this lesson. We've got a chain of logical of like a logical chain of events here. And so I have this written out, and we want to put these in order. It says if you have money, then you can buy stuff. If you pass geometry, then your parents will let you get a job. If you get a job, then you will have money. And if you do your homework every night, then you will pass geometry. So we need to put these in order where it starts out and then ends, and you can connect the chain, I guess. So let's look at this. It says, if you get a job, then you will have money. And then this one would follow next. If you have money, then you can buy stuff. But then there's nowhere where it starts if you buy stuff. So let's see, is there somewhere where it starts or ends with you get a job? That would be here. If you pass geometry, then your parents will let you get a job. And then this one says if you do your homework every night, then you will pass geometry. So it looks like this one's going to be our first one. If you do your homework every night, then you will pass geometry. And then if you pass geometry, this is number 2, then your parents will let you get a job. Then if you get a job, then you'll have some money. And if you have some money, then you can buy stuff. So if you ever read If You Give a Pig a Pancake, this is exactly what we're doing here. We're saying if this happens, then that happens. And if that happens, then this happens. And you just keep following this chain. So the logical chain that follows from this, what you're going to be asked to do is say, well, what can you conclude from that? So we'll start with the first statement. If you do your homework every night, then what's going to happen? So if you do your homework every night, then you will pass geometry. If you pass geometry, then your parents will let you get a job. If you get a job, then you'll have some money. And if you get some money, then finally you can buy stuff. So if you do your homework every night, then you can buy stuff. And this is what the final statement would be when you follow this chain of events and you can make it concise into one single statement. So that's our introduction to logic. Hopefully that helped.